In this video, we're going to go through some geometric gradient practice problems. Our first practice problem is asking what is the present worth of a new computer whose operating cost is $5,000 at end of year 1 and increases 10% per year, telling us that it's a geometric gradient problem, till end of year 3. And the interest rate is given as 10%. So first thing we should do is draw the cash flow diagram. So we know we'll have 3 years. We're looking for the value of P at year 0. And we know that at year 1, it's about 5,000. So C is equal to 5K, and that's increasing by 10% per year. R is equal to 10% until year 3. And then we know that I is equal to 10% as well. So here, we always want to figure out what is the relationship between our growth rate, R, and our interest rate, I. And here, R is equal to I. So we know we can find P from our equation, C times N over 1 plus R, which is the same as C times N over 1 plus I, since R is equal to I. So we'll have 5,000 times 3 over 1 plus, and then we'll write this in a decimal form, so 0.1. So we get 15,000 over 1.1, which is equal to 13,637. So very simple problem to get us started. Let's go to our next problem, which asks, what are the present worth of a project where the operating costs are estimated to be 18K per year and will increase by 5% per year. If I is equal to 6%, what is the estimated present worth after 10 years? So again, let's start by figuring out what we know. So we know that C is equal to 18,000. We know that R, our growth rate, is 5% per year, and I is equal to 6%. So here, R is less than I. And then we know that N, our number of time periods, is equal to 10. So when R and I are different, we know we have to find omega. So for this, omega will be equal to 1 plus I over 1 plus R minus 1. Let's put that in brackets. Okay? And then we just plug in, we know that I is 0.06 and R is 0.05. So we get 1.06 over 1.05 minus 1. And then that's equal to 0.9524%, okay, or 0.009524. So we're going to use this form in our next equation. So we also know when R is less than I, that P is equal to C, our initial value, 18K, times an expression that relates our omega to our present value. So 1 plus omega raised to the n minus 1 over omega times 1 plus omega raised to the n. And we know this from above, and we also know that n is equal to 10. So let's go ahead and plug everything in. P is equal to 18K over 1 plus R is 0.05. And then we're going to multiply it by this large expression. So we're going to add this value, 0.09524 raised to the 10 minus 1 over, again, 0.009524 times 1.009524 raised to the 10th. When we plug this into our calculator, we're going to get 18,000 over 1.05 times a factor of 9.4955. And that's going to help us find P equal to $52,780. Okay. Hopefully this makes sense. We're going to do one more practice problem for this video. This problem asks, for a traffic improvement under study, it's expected to produce benefits of $0.005 per vehicle, so half a cent per vehicle. The demand for the facility is 8,000 vehicles per day. I'm just underlining our knowns. And this is expected to increase 10% per year for the next 10 years. The project will be financed by a bond at 5.77. So I believe that will be our interest rate. I is equal to 5.77%. And then what is the present worth of these benefits? So we're looking for present worth of benefits from year 1 to year 10 for, we don't know C yet. We're going to have to calculate it. So I'm just going to put it as a question mark for now. But we have the inputs for C, which is going to be this benefit per vehicle times this vehicle per day times the number of days per year, because everything else is in years. And we know our R is equal to 10% per year. Okay. So I'm just going to write it out to the side what we know. So we're looking for C. We already know N is equal to 10. We already know R is equal to 10%. And we know that I is equal to 5.77%. So R is greater than I in this case. We also know we'll use this to calculate omega. However, first let's calculate C. So we know that C is equal to half a cent per vehicle times the number of vehicles per day. We know that this should be in years. 8,000 vehicles per day. So we know that these will cancel out. And then we want it in terms of years, days per year. So days will cancel out. And when we multiply this through, we get 14,600 per year. So we're assuming 365 days per year, which I think is a safe assumption. Now let's go ahead and calculate omega. So when R is greater than I, we know that omega is equal to 1 plus R over 1 plus I minus 1, which will be equal to, let's see if this will fit, 1.1 over 1.0577 minus 1. So omega will be equal to 0.04 or 4%. And now we can use our formula to find the present worth for when R is greater than I. So the formula when R is greater than I, the present worth is C over 1 plus I times N is 10 minus 1 over, let's make that needed, over omega. So we know C will be 14,600 over 1.0577 times 1.04 raised to the 10 minus 1 over 0.04. Okay? And so now we can just multiply this through, and we end up getting 165,727. So that's our present worth for this project. So I hope all of those made sense and helped you build a better intuition for geometric gradients, and I'll see you in the next video.